Okay, hello everyone. Today I'm gonna presentation about the data analysis and visualization of IoT sensor data in a smart office system. First of all, my name is Fathir Ade Deo, and then my student number is 23601054, and then my class is 23BCI01. Okay, let's get into the code. Uh, First of all, here's the library. As you can see here, I'm using pandas, matplotlib, and seaborn. And the next cell, we got the load for the dataset. And here's the dataset path and timestamp and hour and data snapshot, data info. And next for the section A. Section A is about room occupancy, trend visualization. Before we get into the explanation, I will explain the legend. I mean the visual. As you can see, here is date and time, and here's for date and here's for time. Like here is 6 a.m., 12 p.m., 6 p.m., uh, 12 a.m., and back to 6 p.m., 12 p.m., 6 a.m., 12 p.m., and repeat again till end. Okay, get into the code. As you can see here's the code. I'm showing about the peak usage and low usage. Okay, back to visual. The time series analysis of the daily occupancy reveals a distinct and consistent pattern in room usage. The office activity typically begins at 8 a.m. with a low occupancy of about 2 people, steadily increasing throughout the morning to reach a peak of approximately 9 to 10 people by 11 a.m. A notable behavior is lunch dip between 12 p.m. and 2 p.m., where occupancy drops significantly to around 4 p.m. Following this break, usage rises slightly in the late afternoon before tapering off as the workday ends at 5 p.m. This predictable fluctuation provides a strong baseline for optimizing building resource. Okay, that's for section A. Let's go to section B. And then here, section B is about correlation analysis. As you can see, here's the code. The correlation, uh, here's the correlation about the occupancy versus temperature. So the correlation is, the code is showing us what is the correlation about occupancy between occupancy and temperature. And then this is section B. The correlation analysis between room occupancy and temperature result in a Pearson coefficient of 0.60, indicating a moderate positive correlation. This statistical evidence confirms that as the number of people in the room increase, the temperature tends to rise. This relationship is logical, as an increase in occupants contributes to the heat load through body heat and the use of additional electronic devices. While the correlation is not perfect, which means implying other factors like external weather or AC lag also play a role, the trend is strong enough to suggest that the HVAC system is reacting to, or is struggling against, the increased human presence during peak hours. The next is the section C. Section C is about energy efficiency recommendation. And here's the code. Okay, and here's the visualization. Okay, in section C, based on the observed data patterns, there are clear opportunities for energy optimization. Optimization. First, the air conditioning usage should be reduced or the temperature set point relaxed during the 1 p.m. till 2 p.m. window. And then during this time, occupancy dropped sharply for lunch, yet the temperature data shows the room often remains cool as if it were fully occupied. Adjusting this could save significant energy without impacting comfort. And then the second is the lightning system appears to be operating suboptimally. The data shows high light intensity, over than 400 lux, even at 8 a.m. and 5 p.m. when only two or three people are present. This suggests the lights are fully on for the entire room regardless of how few people are there. Implementing zone lighting or occupancy sensors would ensure that energy is only consumed to light up occupied desks rather than illuminating an empty room. Okay, so for the conclusion, this analysis proved that energy efficiency relies on aligning building systems with real-time occupancy. The data shows a clear link between user presence and temperature, which means that the correlation, and then yet HVAC and lighting continues to run at full capacity even during low traffic periods like lunch breaks. By simply automating AC reduction during these dips and using sensors to control lighting the office and can eliminate significant energy waste and achieve a smarter, sustainable environment without sacrificing comfort. Okay, so that's all from me. Thank you for your attention and see you.